just come on in whenever, that's fine.
Sorry.
Eat a biscuit, you know, whatever, that's fine. Don't mind me, I'm just a teacher. All right, you wanted me to look up and see if you did anything. Let me look and see. Section 12, there you are. Great book. Mr. Bright, this student is failing. It says you made an 87 on your Unit 1 test.
Okay, I was just wondering.
This student should quit school. That's what it says. Why ain't you got all hundreds on your homework, Mr. Bright?
The last part.
I just-
I did all the
Such a
1 through
disappointment.
2, 1 through 2, and then that chapter 3.4.
And then you just gave up.
Yeah, I just kind of gave up on that
Okay,
last
just
part.
gave up. Just say you gave up. I give up. Let's look and see how everybody else is doing. Chapter 1 test. This average is 86.1. That means I'm a fabulous teacher. Oh my gosh, no zeros. Wow. Mr. Bright, that's unusual, isn't it? Usually there's at least 1 or 2 lost puppies in the class that don't, you know, I'm registering for the first time 5 weeks into the semester, you know. Usually there's 1 of those in the class. Wow. Can't believe nobody got a 0 on the first test. I think this is a first. Y'all a sharp class. That's what it is. Now, let's make fun of everybody who hasn't done their homework. I gotta make fun and discourage y'all somewhat. Let's see, homework. We're on 4.4, 4.3, something like that. No, 4.4, right? Yeah, multiplicative law. Oh, there we go. There's a bunch of zeros. Yeah, there we go. I knew I'd get to the real thing. There we go. Got 2 people working on chapter 4 material. 2 people. That's good. Oh, y'all suck. Good. I don't know what I'm gonna do. All right, let's take a look at 4. I think we went over 4.5 or 4.4 last time. I may skip a section here. I don't know. Sometimes I skip sections. So let's look and see. And I know I got some questions, so just chill out. You'll be all right. Chapter 4. Somebody look in the syllabus. Did we go through 4.5 and 4.6? I know we've done 4.2, 4.3, and 4.4. What does the syllabus say? Everybody should have your syllabus page in your notebook. I don't know why y'all are looking for it. Oh well. I don't usually cover 4.5. That's why I was asking.
Yeah, it says it on there.
Does it say optional or does it say we have to?
It didn't say optional.
No, we're just gonna make it optional. We're gonna go into 4.6. So that means you need to what? Skip 4.5. That's one of the benefits of not working ahead. Okay? All right. 4.6, which will make up about half of your test. We're good? On the Unit 4 test, the Unit 2 test, which is broken up into 2 tests, Chapter 5, Chapter 4, Chapter 5. The Chapter 4 test, half of your test is going to come from 4.6. Why? Because you need it. First off, starting with permutations and combinations on page 175. Make sure you know what permutations and combinations are. What's the difference between them? Well, the difference between them is permutations is order and combinations is what? Without order. Okay? Permutations, president, vice president, secretary, and treasurer. You see any questions with that? You've got a permutation. If you see a question about a combination, a access code and an alarm system, and it has to be in order, access code in order, you're talking about a permutation. Anything having to deal with what? Order is a permutation. Anything not dealing in order is a combination. Most of you lottery questions are going to be combinations because you can win the lottery. You don't have to have it in what? Order. So when you do achieve the status of being able to tell the future, and then you go to the Sphinx down here to buy a lottery ticket so you can win a couple of $30 million, you don't have to do it in order. Even though you probably will, because you know what? You know how to predict the future. So you know exactly what numbers are going to come in whatever order. But anything having to do without order, you're usually talking about a combination. Both of these guys use this guy. An exclamation mark? No. In mathematics, it's called factorial. Now, what is a factorial? Factorial is basically the product of numbers in their natural order, excluding zero. Now, why would we exclude zero? Product means what?
Multiplication.
So if you multiplied by that zero, what would happen?
You'd get zero.
So everything would be zero. So you have to exclude zero. So factorial is the product of that number to 1 in its natural order. Now this is a Hubertism definition. You're not going to find that in any book, but that's basically what it is. Let me give you an example. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is what? 120. And 120 times 1 is 120. Now let's see how many rocket scientists we got out there. 6 factorial would be what? 6 times 5 times 4 times 3 times 2 times 1. Or what? 720. 6 times 120. Which is 6 times, and I'm just going to put a little 5 times 4 times 4 times 3 times 2 times 1 and close the brackets. 6 factorial is basically 6 times what? 5 factorial. Which is 5 factorial is 120. So 6 times 120 is what? 720, Hubert. Thank you, class. So what would 7 factorial be? 7 factorial would be 5, 0, what? Or 5, 50, 49, whatever. Be 7, 49, be 5, 0, 4, 0. Somebody check me. 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's going to be 5, 0, 4, 0. Somebody check me.
That's right.
Of course it is. Yeah, dang old 7 times 7, 20. 7 times 7 is 49. And then 7 times 20, dang old do it in your head. So what would 8 be? 8 would be a BA number. Dang old 40,000 something. All right? The whole point is that you understand that when we're talking about counting, and that's what 4.6 is called, we're not talking about 1, 2, 3, 4. We're not talking about that. We're talking about taking numbers and using formulas with factorial, which is the number in its natural state multiplied so many times. So 3 factorial would be 6. Right? 4 factorial would be 4 times 6, which is 24. And so on. So you need to know how to do this for the test. You're talking about one question. And I usually put one question on the test that says, give me like 6 factorial. You know, so hopefully if you get it wrong, just don't tell anybody. Okay. There is a key on your handy dandy calculator. And it looks like an exclamation mark. It's under your math key. So you go to Stat. It's under the Stat key. I forget from time to time. I don't use the calculator that much. No, it's under the math key. There we go. Math, probability, and number 4. Now, how far can you go? Well, I think it's 72 or 73. Somebody check me right quick. 72 factorial, math. Okay, let's try that again. I don't know what happened there. 72, math, probability, factorial, and enter. There it is. 72 factorial is about as far as you can go. I think you can do 71. So second function, entry, thing will back up, 71. No, you'll have to figure it out. 77, it's somewhere around there. I can't remember where it is. Second function, entry, go away. Second function, entry, about 65 here. There it is. Between 65 and 70, it cuts off. You can't do it. Okay, so if I give you 36 factorial, make sure you can do 36 or 42 or 5 or 7, or make sure you can do it on your calculator. Dang old 36 factorial will still be a number. 3.7 times 10 to the 41st power. That's how much money you could win if you could tell the future. If you could see into the future. All right, and y'all go home and do your homework now. All right, is that y'all good? Y'all ready to do your homework now? All right, now with your handy dandy permutations comes some formulas. Now they've got all the formulas on the next page, probably on page 176, and there they are. They give you examples. All you need right here for this portion of the test is that green sheet right here. It's on page, those 5, only we use 4, those 5 formulas. And they even give you an example on each one. The fundamental counting rule. Basically, when you are given a, I don't know, let's say that your key code in your alarm system takes 1 letter, I think this is an example they use, 1 letter and 1 digit from 0 to 10, or 0 to 9, which is 10 digits. Then you would multiply 26 times 10. And that's the different number of combinations. That's the fundamental counting rule, and that is number 1. So write that down, because there will be a test question. And there is some homework questions like that. And the students, y'all send me these questions because y'all don't read number 1. Y'all go straight down to number 4 and number 5, 3, 4, and 5, and y'all don't even read these 2. Fundamental counting rule. And here's your example. For a 2-character code consisting of a letter followed by a digit, the number of different possible codes is 26 digits times how many, or 26 letters of the alphabet times 10 digits. So there's 260 different combinations. A1, A2, A3, A4, A5, A6, A7, A8, A9, and then stops. A0. B1, B0, B1, B2, B3, B4, B5, B6, B7, 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 B8, B9, C1, 0, C1, C2, C3. Try to do that very fast. It'll mess your mind up. Whew. Say Fuddruckers 5 times real fast. All right. Factorial rule. Y'all awake or what? Miss Long, are you awake? Somewhat. Okay. Miss Long, I can always depend on Miss Long. Factorial rule. Example. The number of ways you can arrange letters. Like smile. Smile. S-M-I-L-E. How many different words? Now, do the words have to mean anything? No. It just says different arrangements. Well, smile would be 1 S-M-I-L-E. 5 factorial would be 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So there'd be 120 different arrangements of the letters in smile. Okay? So when you're talking about letter arrangements, you're talking about number 2, the factorial rule. Now, which one is going to be used in most of the tests? Well, there they are. Okay, now, I usually do this one, do number 3 and number 5. If you want to do number 4, that's just going to be in your homework if you have some. I usually do number 3 and number 5. Now, how do you know when to use permutations? What does it say? When what is used? Order. Example, if 5 kittens, 5 letters, where did I get kittens? I have no idea. If 5 letters, A, B, C, D, and E, are available and 3 of them are to be selected without replacement, the number of different permutations are as follows. Well, that would be N. N is always your biggest number. So what's your biggest number? Well, the letters are A, B, C, D, and E. That's 5 letters. And let's see, 3 is going to be your lower number. So which one's your biggest number? 5 or 3? 5. So it's going to be 5, permutation, 3. Well, how do you know the 3 goes in the N spot? I mean the R spot. Is because N is always your biggest number. Okay? N is the kite, and the other number is the tail. It follows along. You just need to worry about N. And N is usually your biggest number. And you plug it in that formula and you do all the tedious math. Or you can what? Use your calculator. Now this is when I actually tell students to use their calculator in this chapter, in this section. This is the first section that I actually tell you to get your calculator out. And you type in math, probability, and look at number 2 and number 3. What is number 2? It's got a BAP there, right? And what does that BAP stand for? Permutation. What does that BAC stand for? Combination. And that's the 2 that you use. Alright? Let me give you an example. Let's say that you're wanting to win the lottery. And of course, that's what test questions you're going to get is lottery questions. And the lottery is 5 numbers. This is one of the lotteries. 5 numbers. And you have each number from 0 to 9. No, not 0 to 9. 0 to 49. So, which one's in? 49. Good. 49. Combination of what? 5. 5 is the smallest number. 49 is your biggest number. So you punch that in your calculator. Why do I use combination? Because lotteries are combinations. unless there's a stipulation in the ticket or the game that you're playing that says the numbers have to be what? In order. If there is a stipulation of order, then it's a permutation. So you got to reach up. Now, if you wanted to use, if you just want punishment, and you're wanting to use the formula, then knock yourself out. The formula is, wherever it was, there it is right there. Permutation, now this is when all of the items are different. There it is. And when some items are identical. That's why I just use this one, because once you use the lottery number, what happens to the lottery number? Does it go back into the bowl, or do they pull it out and put it up on something? They do something with it. All right? So they don't take the number and put it back in the bowl. So you can't use the same numbers twice. So I use 3, and so that's going to be n factorial over n minus r factorial. So here we go. N factorial over n minus r factorial. So that's going to be, which one's n? 49 factorial over 49 minus what? 49 minus 5 factorial. So that's going to be 49 factorial over what? 44 factorial? Now, somebody tell me what we're actually talking about here. 49 factorial over 44 factorial. You're actually talking about 49 times 48 times 47 times 46 times 45. How'd you know that, Hubert?
5 numbers.
Yeah, why are those 5 numbers? You got 49 factorial over 44 factorial. What happens to 44 factorial down to 1? Did it just disappear? No, it cancels out. Think about it. What is 49 factorial? 49 times 48 times 47 times 46 times 45 times what? 44 times 43 and so on, right? And what's 44 factorial? 44 factorial times 43 factorial. And what happens to those? They cancel out and you're left with basically this. A lot of people don't even realize that. That's how you actually get the answer. You take, in your calculator, you either punch these in your calculator, or, am I doing permutation or combination? I might have done permutation, I'm sorry. Let me look, see. Yep, I did. Times r factorial, which is n minus r factorial times r factorial, sorry. So let me go back and put r factorial back in there. I'm doing permutation right now, but it doesn't matter. Permutation, you see basically in the permutation, these guys right here go out and you're left with 49 times 48 times 47 times 46 times 45. Now if you do that in your calculator, you're going to get the same number as if you did 49 permutation of 5. That's going to give you the same number. Okay? So, if you're doing a permutation problem, you can basically just cancel out whatever's going to cancel out and just multiply those numbers. Okay? Now with the combination, you got to multiply by what right there? R factorial. If you look at your combination rule, you got to multiply by R factorial right here. So, multiplied by R factorial, which is what? 49, the 5 factorial right here. And that's 44 times 5 factorial. Well, again, the 44 factorial still goes out right here, so you're left with 49 factorial, or 49 times 48 times 47 times 46 times 45 over 5 times 2 times, 5 times 4 times 3 times 2 times 1. Isn't that 120? So you got this BA number right here over 120. So that's the difference between the permutation and the combination. The permutation, you just multiply it by this. The combination, you multiply by this. There's the permutation, and you divide it by r factorial. That's the difference between the two. Now, on a scale from 1 to 10, with 1 being, I don't want you to use the formulas, and 10 being, I do want you to use the formulas, I'm about a 2 or 3. I really don't want you to use formulas because your calculator will do it, and I'll show you how to do it on the spreadsheet. In case you don't have a calculator or you can't steal one or borrow one, I'll show you how to do it on the spreadsheet. You just got to type in a word and the number, and it'll give you the answer. Okay? So, this is I really would like you to use your calculator. Then I would like you to use the spreadsheet if you don't have a calculator that does it. And then, for those people that cannot use either one of these, then you're going to have to use the formula. But I am not a proponent of using the formula because you're going to have umpteen questions on this test. You don't need to spend time doing it by hand. But if you want to, that's fine. I'll show you how to do it. It's not a big deal. Okay? Now, let's look at one. What are we going to look at? Well, let's do the South Carolina Education Lottery. I love doing this because I talk about it a good bit. I like to play it every now and then, but I don't go out, my kids being in diapers out in the parking lot, playing in the parking lot while I'm playing the lottery. I don't do that. But I do go by when it gets up to 200 million or 300 million. I will buy 10 or 20 tickets just for the heck of it. All right? I do it about once. Well, how much does it get up to? How many times does it get up to 200, 300 million? Very rare. So, we're going to go to our handy-dandy internet, and we're going to pull up South Carolina Lottery System. South Carolina Education Lottery. And we're going to go to the Powerball. And we're going to go to how to play. I want y'all to read how to play. There's how you play right there. Select 5 different numbers. Those are the white balls. From 1 to 59. And then 1 ball from what? 1 to 35. So how would you do those odds? Well, first of all, let me ask you a question. Whenever you're doing a lottery question, now remember this, I want everybody to listen because you're going to miss this on the test and you're going to come to me wanting me to change the answer. And I'm not, because I told you this just like I told Mr. Bright this in 103. In order to win the lottery, you have to what? Huh? Play. Meaning you have to buy a what? A ticket, Hubert. Thank you, class. So, in all of the questions that are going to be on your test and on your homework, if it doesn't say Mr. Bright bought 20 tickets, it's assuming that you're at least buying what? 1 ticket. And if you don't remember that, you're going to miss 2 or 3 questions on the test that are gimmies because all you got to do is just type it in the calculator. But you're going to forget to put it under 1 because it's assuming that you're buying a ticket because you're playing the lottery. The words are, what is your chance of winning the lottery? Okay? In order for you to win the lottery, you have to buy a ticket. And unless it's specified, it's assuming that you're buying 1 ticket. I just want to tell you that because I don't want to hear any of this whining when you miss 3 questions on the Chapter 4 test because of a 1. So, here's your handy-dandy odds right there. So how do you do it, Hubert? Well, the 1 goes in the numerator because it's assuming that you what? Y'all got to remember this right here. Y'all write that down. 5 balls, 1 to 59, and 1 ball, 1 to 35. Everybody got that? So pull up our handy-dandy whiteboard. And it's assuming that we're buying one ticket, and that's the numerator. And the bottom, how many of, from 1 to what?
59.
So that's 50 what?
9.
9. So that's 59 is in. Combination, how many balls?
5.
5. That's the white balls. And then the red ball is what? How many numbers? 35. Combination what? 1. So, that will be 1 over, now this is how you would do it by hand. You would do 59 factorial over 59 minus 5 factorial times 5 factorial. Over, times 35 factorial over 35 minus 1 factorial times 1 factorial. Well, I'll do 1 factorial for you. 1. And when you do that math, basically you're going to get 54 factorial, 59, that'd be 54 factorial, so that'd be 59 times 58 times 57, 56, 55 over 120 times 35 factorial, which would be 35 times 34 times 33. Well, it'd be 34, sorry, I forgot about this right here. So 35 minus 1 is 34, so it'd be 35 factorial, or 35 over 1 factorial, right? Which is 1, so that'd be 35, I guess. You'll have to check that, but I don't do it by hand, so I don't know. And all of that's over what? 1. And then multiply all that out, and you'll get your answer. I'm not doing all that. Okay, so that's how you would do it if you were, and you're talking about a BA number here. You're talking about a BA number here, and then you're multiplying that BA number times 35, which is going to give you an even bigger number. But we're going to do it like this. I'm going to take my handy dandy eraser, and we're going to erase all